Hi there. This video is about molecule and classification of molecules. Before we plunge into the classification, let us first see what a molecule actually is. Molecule is the smallest particle of a chemical substance which can exist independently in nature and exhibits all the chemical properties of that chemical substance. In actual, the molecules, they are the result of covalent bonding between two or more atoms. Molecules are actually much more stable than individual atoms. The reason is that since molecules are formed by chemical combination between two or more atoms, and we know that chemical bond formation is always an exothermic process, so during this combination of different atoms or similar atoms together, it releases energy from the system, and as a result of that the chemical system gets much more stabilized, and thus the resulting particle, which is a molecule, that becomes more stable than its constituent atoms. Now let us see that why some particles are said to be the molecule and the others cannot be termed as the molecules. For example, here we have some particles. For example, this is a hydrogen atom, this is oxygen atom, and this one is the nitrogen atom. These particles, they cannot exist freely in nature, hence they cannot be said as molecules. Similarly, sodium chloride cannot exist freely in nature, hence cannot be said as molecule. Silicon 4 oxide, sometimes also called as silicon dioxide or quartz, it also does not exist independently in nature and hence is not a molecule. Aluminum carbide with formula Al4C3, it also does not exist independently in universe, hence it cannot be said as molecule. Since all these particles, they do not exist independently in universe, they do not exist independently in universe, hence are not molecules. Whereas these particles, they can exist independently in universe, means they are capable of existing freely in nature, and thus they are said to be the molecules. For example, this particle is actually a hydrogen molecule. It consists of two hydrogen atoms which are linked together by a single covalent bond. This is the oxygen molecule. In oxygen, both the oxygen atoms, they are held together by double covalent bond. This guy is a nitrogen molecule in which both the nitrogen atoms, they are glued up by triple covalent bond. This is say for example neon or any noble gas. It also can exist freely in nature, hence this particle can also be said as a molecule. Actually it is a monoatomic molecule. In this case, this central atom is oxygen, and these are the hydrogen atoms which are bonded to it by a single covalent bond, and this group of atoms, since can exist independently in nature, hence it is a molecule. It is actually a water molecule. Now let us write their chemical formulae. Hydrogen, this is oxygen, this is nitrogen, this is neon, and this one is water molecule. All these particles, since they are stable enough to exist independently in universe, hence they are called molecules. They are capable of independent existence, therefore they are molecules, hence they are molecules. So up till now we have concluded that any particle of a chemical substance which is capable of independent existence, that is said to be the molecule. And generally the molecules, they are groups of same or different atoms which have chemically glued up together to exist as discrete entities. Now let us move on to the classification of molecules. Molecules of chemical substances, they can be classified on the basis of different factors, which are nature of constituent atoms, atomicity, polarity, and molecular geometries. In this video lecture, we will remain confined to the first two types of classifications of molecules. Let us move on to the first classification, that is kinds of molecule on the basis of nature of constituent atoms. The constituent atoms are actually the atoms which are chemically combined to give rise to the molecules. On this basis, the molecules, they are of two kinds. Number A, molecule of element, and number B, molecule of compound. Molecule of element, they are also called as homonuclear molecules, or sometimes also called as homoatomic molecule. The prefix homo of the term, it means same or identical. Since atoms are forming these molecules, they are of same element, means they have same nuclei. Therefore such molecules are called as homoatomic molecules or molecules of element. These molecules, they are actually the representative particles of molecular elements. For example, in this case, it is a hydrogen molecule. It consists of two atoms. It consists of two atoms which are of same element, that is hydrogen. Therefore it is a homonuclear diatomic molecule. This is an example of oxygen molecule. In this oxygen molecule, both the oxygen atoms, they are held together by double covalent bond, and since both the atoms are identical, therefore it is another example of a homonuclear diatomic molecule. This is an example of another homonuclear molecule, but now there are three atoms which are held together by covalent bonding, and this is actually the ozone molecule, and it is homonuclear triatomic molecule. Here is an example of another homonuclear diatomic molecule, which is nitrogen, and this guy here is P4 molecule. It is P4 molecule, phosphorus molecule, which is tetraatomic homonuclear molecule, and these are the positions of nuclei of phosphorus atoms, and these phosphorus atoms, they are held by covalent bonds with one another in such a way that each phosphorus is covalently bonded to three other phosphorus atoms. The geometry of this molecule is tetrahedral. Now let us move on to the second type of molecules based on the nature of constituent atoms, that is molecule of compound. These molecules, they are also called as heteronuclear molecules, or sometimes also called as heteroatomic molecules. The prefix hetero of the term, it indicates different. Since these molecules, they consist of two or more atoms of different elements, hence they are called as molecule of compound or heteronuclear molecules. They consist of two or more atoms of different elements. For example, here is an example of hydrogen chloride molecule, that is HCl molecule. In this molecule, hydrogen is singly bonded to chlorine. Since nuclei of both the bonded atoms are different, therefore it is an example of heteronuclear diatomic molecule. This is the water molecule. It is another example of a heteronuclear molecule which is triatomic. It is an example of carbon dioxide. This is the carbon atom, and these are the oxygen atoms. Each oxygen atom is doubly bonded to the central carbon atom to form carbon dioxide molecule, which is another example of heteronuclear triatomic molecule. This is an example of sulfur trioxide molecule. This central atom is sulfur, and it is bonded to 3 oxygen atoms by double covalent bonds to form this triatomic molecule, and its molecular formula is SO3. This is sulfur trioxide molecule, another example of heteroatomic molecule. Now let us move on to second basis of classification of molecules, and this classification of molecules is based on the atomicity. Now before discussing this classification, we have to know about the atomicity of a molecule. Atomicity is another chemical term, and it is actually the total number of atoms, number of all atoms per molecule of a substance is called atomicity of that substance. On this basis, molecules are classified as monoatomic and polyatomic molecules. Polyatomic molecules can be further classified or grouped up into diatomic, triatomic, tetra, penta, hexaatomic, and so on molecules. Now in this case, the first example which we will take is the monoatomic molecules. Monoatomic molecules, as it is obvious from the term, the prefix of the term indicates that these molecules, they consist of only one atom, since mono stands for one, and these are the molecules which actually are the atoms of noble gases. For example, this is helium. Since it can exist independently in nature, therefore it is a molecule, and as it consists of only one atom, therefore it is an example of a monoatomic molecule. This is neon, and this fellow here is argon. Similarly, krypton, xenon, and radon, they all are the examples of monoatomic molecules. All the noble gases, they exist as monoatomic molecules. Since their molecules, they consist of only one atom, means their atomicity is 1, therefore they are termed as the monoatomic molecules. Their atomicity is 1, hence they are monoatomic molecules. Now let us move on to second kind of molecules on the basis of their atomicity. And these are the diatomic molecules. Diatomic molecules, it is obvious from this term, diatomic. Di stands for 2, means these are the molecules which consists of 2 atoms. These are the molecules which consist of 2 same or different atoms. It means that atomicity of such molecules is 2. Atomicity of such molecules is 2. Let us look at some examples. Here is a hydrogen molecule. Since this molecule consists of two atoms, therefore it is a diatomic molecule. This is an example of hydrogen chloride molecule, and other diatomic molecule, but in this case it is a heteronuclear diatomic molecule. And other example is carbon monoxide molecule, which is heteronuclear diatomic molecule. Since molecules of these chemical substances, they consist of only two atoms, whether they are different or identical, hence such molecules are called as diatomic molecules. Now let us move on to the triatomic molecules. This is a third type of molecules on the basis of atomicity, that is triatomic molecules. In case of triatomic molecules, the molecules, they consist of three atoms. Atoms can be identical and can be different of such molecules. Tri stands for three, means such molecules they have their atomicity equals 3. For example, here is a water molecule. We can see this entity. It consists of three atoms, 2 of hydrogen and 1 of oxygen. Therefore it is a triatomic molecule. Since all the atoms, they are not of the same element, hence it is an example of heteronuclear triatomic molecule. It is water molecule and the number of atoms per molecule are 3, therefore its atomicity is 3. This is ozone, which is another triatomic molecule, but now in this case all the three atoms are of same element, that is oxygen. Therefore it is an example of a heteronuclear triatomic molecule. Let us look at another example, which is carbon dioxide. It is another example of a triatomic molecule. Now let us look at the molecules which have their atomicity 4. Such molecules, on the basis of their atomicity, they are classified as the tetraatomic molecules. Tetraatomic molecules. Tetra stands for 4. Since these molecules, they consist of 4 atoms of same or different elements. Such molecules, they consist of 4 same or different atoms chemically glued up together. Chemically glued up together means their atomicity is 4. Atomicity of tetraatomic molecules is 4. It is obvious from the chemical term. Tetra stands for 4. For example, let us look at this molecule. It is actually the ball diagram of ammonia molecule, in which nitrogen is the central atom and the 3 hydrogen atoms, they are singly bonded to nitrogen atom to form ammonia molecule. Formula of ammonia molecule is NH3. It is obvious that this molecule consists of 4 atoms, of which 1 is nitrogen atom and 3 are hydrogen atoms. Therefore the total atoms per molecule are 4. Therefore it is an example of a tetraatomic molecule. Let us see another example. It is actually the sulfur trioxide molecule. The central atom is sulfur, which is surrounded chemically by 3 oxygen atoms by double covalent bond. Since this molecule, it consists of 4 atoms in total, 1 of sulfur and 3 of oxygen. Therefore it is another example of a tetraatomic molecule. Likewise, another tetraatomic molecule is P4, which is tetrahedral in geometry. We have discussed already in this video. Let us move to another kind of molecules on the basis of their atomicity, that is pentaatomic molecules. or pentaatomics. Penta stands for 5. These are the molecules which consist of 5 atoms per molecule. It means that their atomicity is 5. Let us take some examples to explain the pentaatomic molecules. Look at this molecule. It is actually methane molecule. The central atom is carbon, which is singly bonded to 4 hydrogen atoms. These hydrogen atoms, they surround the central carbon atom tetrahedrally. Therefore its geometry is tetrahedral, and the molecular formula of this molecule is CH4. It is obvious from this molecular formula that for carbon atom there are 4 hydrogen atoms, so in total this molecule possesses 5 atoms. Therefore its atomicity is 5, and hence methane molecule is a pentaatomic molecule. Let us take another example. This is a nitric acid molecule. Molecular formula of this compound is HNO3. Molecule of this compound consists of 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atoms. So in total there are 5 atoms in one molecule of nitric acid. Therefore nitric acid is also an example of a pentaatomic molecule. This blue atom is the central atom and is nitrogen, which is singly bonded to this oxygen, and this oxygen in turn is singly bonded to hydrogen, whereas the rest of the 2 valences of nitrogen, they are satisfied by 2 oxygen atoms, each of which has been bonded to it by forming double covalent bond. So this nitric acid molecule is also an example of a pentaatomic molecule. Similarly, the molecules can be hexaatomic, also called as hexaatomics, with atomicity 6, heptaatomic with atomicity 7, and octaatomic with atomicity 8. Now let us have one example in each case of such type of molecules on the basis of their atomicity. For example, phosphorus 5-chloride, also called as phosphorus pentachloride, is an example of a hexaatomic molecule. Sulfuric acid, which is also called as the king of chemical, is an example of heptaatomic molecule since its atomicity is 7. Orthophosphoric acid or phosphoric 5 acid is an example of an octaatomic molecule. Now there are certain molecules which have very large number of atoms in them, and those molecules, they are called as macromolecules or polymers. The word polymer has been derived from 2 Greek words. That's polus, means many, and meros means parts. So it means that many simple molecules, they repeatedly link up together to form polymers. Polymers are also called as macromolecules or giant molecules. Giant molecules. There are a number of polymers known to us. For example, quartz, rubber, diamond, silicon, polythene, polyesters, DNA, proteins, etc. They all are the polymers. Here we take an example of a simple addition polymer, that's polythene. Polymers are the macromolecules which are formed as a result of chemical process called as polymerization. polymerization is of two kinds, that is addition polymerization and condensation polymerization. Keep in mind that polythene is an example of an addition polymer. In the formation of polythene, n number of ethene molecules, they are repeatedly linked up together to form long chain of the molecule, such simple molecules which are repeatedly linked up to form polymers, they are called as monomers. Molecular formula of ethene is C2H4. So n number of such molecules, when they are subjected to addition polymerization, they link up repeatedly to form long chain of polythene polymer. These are the carbon atoms. There is single bond existing between them now. After the polythene is formed by the addition polymerization of ethene molecules, and to each carbon there are two hydrogen atoms which are linked to carbon atoms by single covalent bonds. Now the unsatisfied valency of each carbon is extended out of the bracket. That indicates that this unit enclosed in the bracket is repeated n times. The part of the polymer chain enclosed in bracket is called as the repeat unit or repeating unit, and this repeating unit may be from few to several thousands depending upon the degree of polymerization, whereas this n is called as degree of polymerization. If you liked the video, please do subscribe my channel and hit the bell icon so that upcoming video lecture on chemistry might not be missed. Sharing is requested too. Thanks for watching.